pretty exciting event to be at today. I want to talk about continuous delivery with Cloud Foundry. And you might be wondering, what do I mean by that? So I think what I really want to say is that you've got, I think a lot of people are familiar with the concepts behind continuous delivery. But what I really want to talk about today is how you can apply those concepts, and particularly how Cloud Foundry is a really, really good fit for building your deployment pipelines and for really getting yourself started. What I also want to say is I want to talk about some of the anti-patterns that you need to be aware of when you're working with continuous delivery in Cloud Foundry. Some of the things you want to watch out for that might mean that you're in some trouble. And I also want to talk about how can you actually apply the same principles, the same practices that you apply to your application code, also apply those to your infrastructure code. So I'm a founder at a company called CloudCredo based in London. And what we do is we build and we manage Cloud Foundry instances for our customers. We also do customizations for them as well. And we were founded last year, and we've seen massive uptake, particularly this year, in people getting very excited about the promise of PaaS, in particular about Cloud Foundry. I'll end the sales pitch there, but we're also hiring. So this is the deployment pipeline, and this is really the core concept that you've got behind continuous delivery, okay? And what this says is that we want our developers to be working in a way where they're making small, discrete changes, and those changes are going through a series of gates, and they're being assessed as to whether or not our code is in a working state. So we start off at one end, right, and we've got some tests that run very, very quickly. So we commit our code, we make a very small change, and our test runs, maybe some unit tests, and we know straight away whether or not we've broken the build. And we go all the way through, down, getting more and more rigorous in the terms of the tests that we apply. So for example, we might run some integration tests. We might stand up some nodes, run some integration tests, and see whether or not our code is working. So we're moving from tests that are very quick to run all the way down through, getting increasingly more rigorous until we know that we've got something that we can deploy to our customer. We've got some level of confidence that it's going to work. So that's really the kind of core concept behind continuous delivery, is the deployment pipeline. But why are we doing this, right? Because obviously this sounds like it's going to be a lot of fun, right? It sounds like it's going to be lots of exciting things for engineers to do automation, and all engineers love that stuff. But why are we actually doing it? What's the rationale for doing it? Well, I think if you've been awake during the last couple of talks, you probably know the answer already. And that answer is it's about feedback, okay? It's about very quickly being able to go from a position where we make a small discrete change, we go through that pipeline, and straight away we get some feedback from the customer. And the reason that we want to do that is because otherwise, if we're waiting a long period of time, if we don't have all this automation in place to allow us to release our software quickly, we're going to have a problem. And that's going to be that we're going to be batching up these changes. We're going to be deploying a bunch of changes in one go. And really, we're missing opportunity to have fast cycle time where we can actually get feedback from our customers. Otherwise, we could be spending lots of time building the wrong thing. So that's really the core reason that we want to be doing this stuff. And from the customer's perspective, right, all that automation, I could have a wonderful pipeline with lots and lots of automated tests, but really, unless the customer's given me some feedback, that's really all for naught. There's no reason for having it there. I mean, from the customer's perspective, all they really care about at the end of the day is the working service, right? So if I'm doing lots of software development, I'm paying for some fairly expensive software developers, right? And we haven't figured out a way to get rid of those people yet, unfortunately. So also, we've got the deployment concerns. We've got to worry about how are we going to deploy our software? How are we going to stand up our software, instantiate some nodes, we're going to deploy it all over the place. That's like hard stuff to do. And if we could avoid having to worry about some of that stuff, that would be a wonderful world that we live in. So where does Cloud Foundry come in? So I guess you could say, like I've just said, we want to remove complexity. We want to remove having to worry about these additional things. But then we've got Cloud Foundry. Cloud Foundry is a fairly complex beast, right? There's a fair number of moving parts. So you might say we're actually adding complexity. But there's a reason that we're doing this. And the reason we're doing it is, as was said earlier as well, it's a very direct mapping. It's a very clear relationship between what somebody who's an application developer wants to do, which is I want to deploy my code, and actually how I do that, right? It's a very, very clear relationship. I'm not having a situation where I've written my code, I'm very happy about, I want to share it with some customers, but I've got to, now I've got to sit down, I've got to figure out how I'm going to spawn some instances, I've got to maybe learn some kind of configuration management tool like Chef or Puppet, I've got to learn how to write Puppet manifests or Chef cookbooks, and then maybe I've got to learn about Capistrano and how I'm going to deploy my application as well. So ideally, as a developer, all I really want to do is just pick up my application and deploy it. It'd be fantastic if I was in a situation where I was, had a nice breadth of skill, and we're all supposed to be generalists these days as well. But the problem with that is I really just want to deploy my application, right? I don't want to spend all this additional effort, and this is really where Cloud Foundry comes in. Cloud Foundry matches my developer mental model of I just want to deploy an application, I just want to bind a service to that application and get going. I don't want to have to worry about firewall rules. I don't want to have to worry about configuring a load balancer, all of that stuff. And the really big benefit is this consistent interface for deployment. So if you think about, in a lot of organizations, right, you'll have a fair amount of rework. So you'll have different teams will say, we need to deploy an application, and they'll each independently come up with their own way of doing that. They'll each write their own scripting, and you've got a fair amount of duplication and waste. With Cloud Foundry, you've got this consistent interface the whole way through, right? So all of your teams are using a shared platform, and they're using the same command line to deploy their applications, right? So across the applications, across the teams, it's the same command line. But more than that, it's also the same command line across different stacks. So if I'm a developer and I'm just getting started with, say, Ruby, maybe I've done a lot of Java development in the past, I don't know how to deploy a Ruby application, but I can get hacking and write some Ruby code. I don't necessarily want to have to learn all the ins and outs about how to deploy a Ruby application in order to get going. What I want to be able to do is just simply run CF push exactly the same as if I was deploying any other application, and I can get it out there on the platform straight away, and somebody can look at it. And this is really the key thing. It's this consistent interface. And if you think about when we're trying to actually plug this into a deployment pipeline, now a lot of those concerns are going away, right? From the perspective of my CI server, say Jenkins or something, I'm just continually calling the same command line, right? I'm just calling, it's very, very simple to compose these pipelines because it's just so straightforward. It's just the same command every time. So I want to talk now about avoiding making breaking changes. And so I think this is a really, really core principle that you need to take away. And it's really about ensuring that your software is always something that's in a releasable state. And so what I mean by that is quite often you get teams and somebody says, I really want to make this large-scale change, but stuff is going to be broken for a while. I won't be able to release the software. And that's not a position we want to be in, right? What we want to be able to do is always say, is our software something that we can release? And we want to ideally always be able to release it. So if a customer says, hey, I want this to be live now, I want it to be useful now, we can deploy it. So I want to tell you about a project that I was involved with where we were trying to apply some of these practices. So basically, we've been reading the Lean Startup book. We played around quite a bit with Cloud Foundry in the past, and we were drinking the Kool-Aid, and we were like, yeah, we want to give this a try. So we'd had a chat with the customer, and we knew what we were trying to build. We knew the basics. And what we wanted to do is we wanted to start on day one of the project and actually deliver some value to the customer, right? We wanted to be able to deploy the application, very, very minimal example to get started with, and then hopefully receive some feedback from the customer as well. So this was the general concept, is we want to have this very fast cycle time. We want to be able to deploy the application, get some feedback, and then iterate from there, hopefully moving closer and closer towards something that the customer wants. So we did that. We beavered away for the first day. We wrote some code. And then we decided to use cloudfoundry.com for that, which is the existing hosted service, because it meant we didn't have to worry about all those deployment concerns I was talking about before. So that was awesome. And then we pushed it in the afternoon, and then we sent an email with the URL to our client. And the client came back. We were sort of patting ourselves on the back at this stage. And the client came back and said, it's rubbish. They said, look, your website, you're using the wrong theme. And your form field validation, you're missing validation on these fields here. And we were a bit depressed about that, actually. But the point is not that I'm a bad web developer, which is probably true. The point is actually that we were able to get that fast feedback straight away, right? We didn't spend lots of time trying to decide what our favorite config management tooling was, trying to decide how we were going to bring up on what infrastructure, et cetera. We got started straight away by building an application and putting it out there in front of the customer and getting some feedback. And I think that's the kind of key takeaway is that the ability to get that feedback straight away and to be able to iterate closer and closer to what the customer wants is really the key benefit. But we didn't stop there. It wasn't just a case of getting started quickly. What we also wanted to do is we wanted to then decompose the application into separate services. So we talked about earlier about having these monolithic applications, and this is where we were. We had one monolithic application. We wanted it to be a situation where we could actually split that out and we could have multiple separate services that were loosely coupled talking to each other. So this is the approach we wanted to go to, and so we did this, and it was fine. And then we were running on version 1 of Cloud Foundry at this time, and we decided, well, we wanted to run it on our own tin. When I say our own tin, it's not our own tin anywhere these days, so this was on EC2 in US East. And we wanted to make some customizations to the version of Cloud Foundry, of Ruby that was there. So we took the Bosch release for Cloud Foundry, and we made some changes to the versions of the software that were there. These days, that's a much less invasive process, but that's what we had to do at that stage. So we did that. And then this particular application had some really quite stringent requirements for availability, and it was actually going to be appearing on like a live Network UK TV event spanning about a 7-hour period. So it was pretty important that the service was available during that period. So what we did is we decided to run it, we'd have multiple instances of Cloud Foundry. We'd have some in US East, as I described, some other stuff running in US West and Ireland, and also in Docklands in London on a vSphere provider there. So we're spanning different EC2 regions. We've got different virtualization technologies in play as well. And we've been able to do that, I say relatively straightforwardly, right? And so to give you a feeling about what the application actually grew to, this is what the application had to deliver. So we were doing 600,000 transactions in 7 hours. We had to build for 500 user journeys every second. And that's not requests, that's user journeys. So this is reasonably significant stuff. And then in addition to people actually hitting the website directly, we also had 10,000 call center operators. So essentially there are people watching the TV. They're going to be on the phone to the call center operators, and there's going to be a heap of traffic coming in through those call center operators as well. So that's what we were building. And it worked, and that was fantastic. And I think due in large part to Cloud Foundry. And the reason for that is because if you think back to the start there, we started off with, as I say, a web app of perhaps questionable quality on the first day. And we scaled that all the way through to something that actually had to deliver to those numbers and had to work on the night. And it worked for us. And the really fantastic thing about Cloud Foundry in this instance is all the time we had this consistent interface to deploy to. So if you think about it, we're making really large-scale refactoring, really large-scale changes to our infrastructure, but the interface that's presented by the PaaS is the same throughout that process. So Jenkins is still going, okay, I want to do a CF push. It's calling out through the CLI, a wrapper around the Cloud Foundry CLI all the time. And that interface isn't changing. We're keeping that interface the same, and we're not breaking the build. There's never a point where we've said, oh, we need to stop now and go away and think about doing things in a different way, right? We're just continually delivering small incremental changes. And that's really the power there is having that heartbeat, having that regular ability to just push out small changes, see the effect of those changes, show them, get feedback from the customer as we scaled up. And I think we would have struggled to do that, I think, with another solution. So production-like environment. So this one's a really interesting situation that a lot of people get themselves into where you've got an application, and maybe you need to rebuild that application as you move between different stages. So you might have an environment which is your development environment, you might have a staging environment and a production environment, for example, and sometimes people find that they need to rebuild their application as they move between those environments. And typically that's a really bad smell that says, oh dear, actually I've got some something embedded in my application, I've got some application logic or something there which is making it very difficult for me to have confidence that as I deploy it between different environments, it's actually going to work, right? So what it actually means is that when I deploy to production, I'm deploying the code for the very first time in production. We don't want to be doing that, right? What we want to be able to do is we want to be able to very easily build new environments, and we want to be able to decouple those environments. We want to be able to decouple those environments from being something that's very expensive to bring up, okay? So we don't want a situation where like typically in organizations, you've got nobody quite remembers how to build a new environment. Maybe there's some manual steps involved. You want to skip around all that stuff, and you want to say, with Cloud Foundry, I can very easily provision a new environment by using the built-in primitives in Cloud Foundry to create new organizations or spaces, right? So that's really, really true. It's all running on the same platform, and it's a great way to get going. Likewise, I want to be able to scale as well. So I want to be able to have some environments that are perhaps running at a smaller scale, and I want to be able to have my larger environments, perhaps a pre-production environment, et cetera, scaling. And essentially, with Cloud Foundry, that's just a case of changing an integer somewhere in a manifest file, right? That's as easy as it gets. This stuff, you don't want to be doing all this stuff manually from the command line. You really do want to be doing this stuff through code. So if you're working with the CF-CLI, you do want to be driving all that stuff through code. You need to be able to say, through the source code history, I can go back and I can reason about the changes that have been made to my deployment scripting. But the point is, once it's all in code, right, once it's all going through my deployment pipeline, I know that I can do this repeatably. If I think there's an issue with my environment, I can shoot it, I can build another one. This is a really interesting pattern, which is about load testing within your pipeline. So a lot of teams, you've got teams that are otherwise very, very agile, right? And these teams may have like cards on the wall and be very much into how they can deliver as quickly for the customer and get feedback. But typically these teams, a lot of people will still go, oh, we're going to have a load testing window, right? We're going to have like 3 weeks where we do some load testing. And we're going to sit down and figure out how to write our load testing scripts again, and we're going to try and remember how we scale our platforms and create new platforms. And it's always a bit of a difficult situation. And what I'm really advocating instead, and what we did is we actually said, let's treat load testing as something that's part of our pipeline. Let's say that it's actually just another gate that we need to go through, right? We need to say, if our software is fit for purpose, it's going to perform at the levels that we want it to perform at. And that means that, let's say that we're actually doing that. We're assessing whether or not our software performs under the load that we expect it to perform under as we make every change. That means that we're not in a situation where we've made like 2 months worth of changes and we're deploying it, and now we've got to try and work out which of those changes has caused a regression where we don't scale anymore, right? So I think having it as part of the pipeline is definitely the way you want to go. And where Cloud Foundry helps you here is the ease with which you can scale up and scale down means that it's not a situation where you have to say, oh, it's so expensive, it's not cost effective for me to do this, to production volumes. Now I can do that because I'm able to scale it up briefly, perform the load testing, and then tear it down again. And I think that's really the mindset that you want to be in. You want to be able to say, yes, I can do this stuff. It's cost effective for me to do it, and the scaling that's built into Cloud Foundry lets me do this stuff. Externalizing configuration. So this one is perhaps, I was actually trying to talk about this one earlier and got slightly confused in my slide order. But what we're talking about here is you've got, what you want to be able to do is not have the configuration embedded within the application, right? So as I was saying earlier, you don't want to have a situation where you're changing the artifact as you move it between environments. What you want to have is a situation where you've got a nice clean separation between the code and the configuration. And there's a website called 12factor.net, which comes from the Heroku team, which I definitely, if you haven't looked at, please look at, because it really talks about this. It talks about having a strict separation between your config and your code. And that really means all the stuff about Cloud Foundry where you're able to bind services and your application comes up and consumes those services. It doesn't have a hard-coded database server IP and port. It's just consuming a service. And that's the way a developer thinks about it, right? I don't want to think about all the infrastructure. I don't want to have to think about this bit of code is running on this node and this other bit of code is running on this other node. I just really want to be thinking about binding services, and I want to be just consuming my settings without it being hard-coded into the application. So reproducible environments. So now we've got a situation where we're moving the same code between our environments, but how can we actually have confidence that our environments themselves are reproducible? And Cloud Foundry is great for this. And obviously we've got one option, which is the PaaS itself. So we can host multiple environments on the same PaaS, and we can have a high level of confidence that it's going to be running the same software, obviously. But then we've then got BOSH, and the fantastic thing about BOSH is that we've got our deployment manifest where we can reproducibly build environments. So I can take an existing deployment manifest, I can use that to bring up a new environment, and if I need to, I can make changes or customizations to that. But the point is, it's all in source control. So if I have any doubt about the environment, I just shoot the environment and I bring up another one with BOSH deploy. It's that straightforward. Something that BOSH gets right as a pattern is artifact repositories. And I think probably a lot of people are doing this already, but this is really something that you probably want to be applying to your application code as well. So this is a situation where I've got an application, but the application has some dependencies on some kind of external resource. So for example, I might have a dependency on a library or a binary that sits outside of my network. And so if I'm building my software or I'm deploying my software, there's a situation where potentially that resource has disappeared. And suddenly I can no longer rebuild the service that my customer depends on, right? So what I've got to do is ensure that I've actually vended, and the Ruby community call this vendoring your dependencies. What I want to be able to do is to ensure that all those binaries, everything I need to rebuild the service, starting from the code all the way up, is all in my artifact repository. And so for Java, I would use something like Nexus for this. If I was doing Ruby stuff, I'd have a gem proxy of some type. And in the same way, if I'm doing Bosch stuff, if I'm building Cloud Foundries, Bosch has got the blob store built in, and that's really all the blob store is. It's an S3 bucket with a bunch of binaries in it. And that just ensures that you have that ability to reproduce the environment. Because if you don't have that insurance policy, you know that on that really important day when you need to build a new environment or you need to deploy something, it's going to disappear. Blue-green deployments, I'm not going to talk too much about this, except to say this is a pattern that the Cloud Foundry makes extremely easy to do, both through the ability to deploy applications so easily and also for the ability to change the mapping at the front so easily, so you can control where the traffic goes to. Yeah, I won't talk too much about that, but feel free to read up on it. So, things to watch out for. We've talked about how Cloud Foundry is a really good fit for this stuff. Let's look at a couple of situations where we need to be a little bit more careful. So one of these is manual application changes. So this is really showing how it's a double-edged sword, right? It's so easy for me to deploy new code. That's fantastic from a developer's perspective, but I really need to ensure that any changes that I make are going through that same deployment pipeline that I talked about earlier. If I'm making changes that are manual, if I'm actually deploying new code, pushing out new code without it going through all of those series of gates that we talked about earlier, I'm going to have trouble because now I can't reproduce my service again, right? I had Bob who went on there and pushed some code, or maybe he opened a tunnel to our service that we depend on and issued some update statements or something. Now suddenly I can't reproduce the state of that service. So it's really important that any changes I made are in source control so they can be reasoned about, they can be looked at, and I can diff them. I can understand what's happening over time. This one's about branching. So Jez Humble, one of the authors of the Continuous Delivery book, which you all need to read, by the way, if you haven't, is really against long-lived branches, okay? And this is quite a controversial one. But essentially what we're saying is, if I'm using Git, it's so easy for me to create branches with Git that I can create branches all over the place, and I can have a long-lived piece of development that maybe runs over 3 or 4 days, 5 days or something. And I'm kind of happy, I'm running in my own little world, and I'm able to run tests and feel like I'm actually okay. But all the while I'm doing this, there's new changes that are dropping into the main line that I'm not getting, right? I'm not actually able to say with any certainty when the customer says, yeah, that looks great, let's push it. I go, oh, well, I've just got to merge it all back in, and I'm going to have 2 days of merge hell or something. In the same way with Cloud Foundry, because it's so easy for me to create separate deployments, right? It's so easy for me to provision new applications. There's a risk there that a developer goes, oh, well, cool, I'll just spin this up, I'll take that code that's on my own branch, and I'll deploy it somewhere. And really, you want to be encouraging as much as possible all of the stuff to go down the main line so that you're able to say with certainty, yes, I've integrated that code. The actual main trunk of what I'm working on is in a releasable state. So we've talked about application code quite a bit. I want to talk a little bit about how we can apply now the same principles we talked about to infrastructure code. So this is your service, right? At the top, we've got our application code. In the middle, we've got our infrastructure code. And at the bottom, we've got our base OS. So in Cloud Foundry jargon, the bottom one is our Bosch stem cell, right? We've got a script that builds our stem cell. In the middle, we've got our infrastructure code. In this case, that's the Cloud Foundry PaaS. And at the top, we've got our application code, which is still our application code. But the key point here is that each of these things actually has dependencies on the other, right? So if I change the script that builds the stem cell, well, suddenly I need to revalidate that all of the levels that sit above that are actually still going to work, right? Because I don't know otherwise. Likewise, if I change some of the code in my Bosch release that defines my Cloud Foundry, I also need to ensure that the application is still going to function correctly. So these interrelationships that are very much like if you have separate libraries or a normal software project, I need to actually kick off a build and ensure that I'm building as these dependencies are updated. If we go a little bit further and we say, okay, how can I apply this further to my infrastructure code? Well, one of the things I can do very easily, we talked about having tests that run right at the start of our pipeline that are very quick to run. One of the things I can do is I can do some validation of my Bosch manifest, for example. So I can say, is that a valid YAML file? Is it well-formed YAML, or does it just break as soon as I try and parse it? Likewise, I can look and I can do some semantic validation of the data that's in that manifest, and I can say, for those IP addresses and for those IP address ranges, do they actually go together? Does it make sense? Is that IP address valid for the range that's been specified? Once I've done that, and obviously really what I want to do is as soon as I commit a new version of the manifest, I also want to kick off a deployment. I want to prove that that manifest actually results in a working service. But then I also want to think about changes to my BOSH releases themselves, right? So I want to say, if I change the release code, I want to automate the upload of that to the director. I want to kick off a deployment, and I want to say, yes, I can see that that works. And there's no reason you can't automate all of this stuff, right? All of this stuff is just simply available through a command line that's very high level, or it's all relative, but it's very high level. And so it's very easy for you to drive this stuff through Jenkins and automate the whole thing. Going for extra credit, one of the things that we can do is we can automate the updates from upstream releases as well. So for example, if we have changes to the Cloud Foundry release that these guys are busy hacking away on, and it never breaks, right? It's always okay. We want to actually ensure that we know whether or not all of the stuff that runs on top of that is going to work correctly. So if there's some updates to the versions of the software that are being used, any of that kind of stuff, we want to know, does our platform still work? Do the applications that run on that platform still work? And again, this is just a simple case of expressing those dependencies in a way that allows it all to be built. Likewise, if there are some binaries that are embedded in our releases, maybe these are, quite often in BOSH releases, you don't necessarily use OS packages. So in that case, you're wearing the burden of actually coping with changes between binary versions. So we want to know when a new version of Redis is available that fixes that critical security fix that we need to fix. So you can automate that stuff as well, right? It's just effort. It's all just effort. But the point is, the more you automate, the more confidence you can have that your service is going to work properly. So key takeaways I want you to come away with today. Cloud Foundry really does make building continuous delivery pipelines so much easier. We found it helped us massively just in terms of the ease, and the level of abstraction is really well suited to the way that you want to think about the problem as a developer. Cloud Foundry makes it really easy for you to do the right thing. So just by naturally, kind of the patterns we talked about, like the externalizing the environment configuration, is just something that is the default in Cloud Foundry. So you don't kind of fall into these traps. Cloud Foundry is just naturally a good fit for continuous delivery. And then I think the really key one is that PaaS abstraction, having that abstraction in place, allowed us to grow from a very small scale all the way up to a very large scale. So we started off with that very slightly dodgy app at the beginning. We built it right up to a real production system that was handling some significant volume. And we did that all the time just talking to the same abstraction. Jenkins was still talking through to the same abstraction. And we had a steady heartbeat. We weren't breaking all the time. So I think it would have been difficult to do that with another solution. So that's everything from me. Thank you very much for listening. And drop me a line if you have any thoughts. Thank you.